Right, welcome. This is Gateway 1 of Coast. So in this chapter, we'll be looking at how and why coastal environments are different and dynamic. Let's start with some basic definitions. So the area nearest to the land itself, the dunes, is your backshore, and you approach it where you see the sandy area that's considered the foreshore. Near shore is the point where your low tide actually is marked between the low tide onwards into the sea, and offshore is the area where you have deeper waters. Now on this diagram here, you do see indication of MSL, LT and HT. HT refers to high tide, MSL is the mean sea level, which is the average height of the water at most times, and LT is of course low tide. Coastal environments are very dynamic environments, and there are four main factors that affect the coast itself. First and foremost, of course, it is the waves. So by the waves itself, when they come into interaction with the coastal environment, it actually alters the coastal environment. The other factor is of course tides. Tides are your alternating high and low in a day, which controls the rise and fall. Tides are directly due to the gravitational pull of the moon and the sun on the earth. It produces a cycle, two highs and two lows every 24 hours. The other two factors that affect coastal areas are currents. Now, currents are basically your large-scale water movements within the sea itself. They're driven largely by the prevailing wind conditions, which generally blow in one direction. However, as many of you would have realized if you've been to the coast to do coastal fieldwork, currents can switch, and at one particular location, it is not always in one direction. Now, the final factor, of course, is geology, which is the type of rock you find at the coastal area itself. Now, different types of rocks have different types of resistance levels towards erosion. So if you have very resistant rock, the coastal landscape will be able to hold its overall shape for a longer period of time. If you have very less resistant rock or very weak rocks, then the landscape will be very dynamic and will change constantly. Now, it's important to note that waves are developed when you have energy from wind blowing across the sea and it's transferred onto the water surface itself. Movement of waves is directly affected by the wind direction, and generally onshore winds push waves towards the coast, resulting in this crashing effect onto the shore itself. Now, what you see in this diagram here are the wave terminologies. You do need to know what wavelength refers to, what wave height refers to, where you find your crest, and where you find the trough of the wave itself. However, these are general information that is good and useful when you're describing strength of waves as well as impact on the coast. More importantly, there are three factors that will affect the wave energy itself. So the three main factors are of course wind speed, wind duration, and fetch. So if you're talking about wind speed, the faster the wind blows, the greater the wave energy will be due to the transference of energy from the wind itself to the water surface. For wind duration, the longer the wind actually blows, you will also consequently have a larger wave because there's more energy that's being released onto the water surface itself. Now, the third one is an interesting concept called fetch. So fetch basically is the distance that a wave can travel before it hits a coastal area. So for coastal areas, not every area along the coast enjoys the same length of fetch. So if you do have a larger fetch on one coast versus the other coast, the one with the longer fetch or larger fetch will develop stronger waves. Now, strong waves is essential for certain sea sports like surfing. This next diagram here shows you the behavior of waves as they approach the coastline from deep sea. So in the ocean itself, in the deep ocean, the waves adopt a circular rotational manner as it moves towards the coast. Now, as the seafloor starts to rise upwards, as you get nearer and nearer to the coast itself, this circular motion is now shortened, so it becomes a ovular shape, and it gets narrower and narrower. Now, at the point where the seafloor is now significantly steep enough, it actually slows down the bottom of the wave, and the top of it will crash over, forming a break. Now, that is the point where surfers like to surf on. So this is why when you're surfing, you're actually near the coast itself, at the break where the waves break. This concept of breaking is very important. You have to realize that as the seafloor is nearer and nearer to the top of the wave, this breaking actually forms a drop with a lot of energy, and this is also related to the formation of tsunamis, which you will learn later on when you do plate tectonics. Now on the beach itself, you have two types of wave movement that you will see. The inward waves that come towards you is called the swash, and the one that moves backwards after it hits the coastal area is called the backwash. So due to the variations in strength of the swash and the backwash, you end up with two different types of waves. One is called constructive wave and the other one is called destructive waves. So looking at constructive waves, what the general idea is, your swash is weaker than your backwash. So as it comes in, it brings in with it sediments and particles, and because the backwash is weak, now at the point where it crashes against the shore, it deposits everything. Destructive waves, what we're looking at is waves which have a lot more energy when it arrives at the coast itself. So what happens here is not that there is a strong backwash stronger than the swash, because backwash itself cannot be stronger than the swash. So what happens is the swash is so strong, and upon impact on the coast, it does a very strong erosional action on the coast itself. So when you're doing this, the backwash is allowed to bring not only materials that it brings in, but additional material that has been eroded away is also swept together by the backwash. So in totality, your coastal area is being destroyed. That's why this is called a destructive wave. Now I want to bring you briefly through this concept of wave refraction. Wave refraction is basically the process where your wave change direction as they approach the coast. As they approach the coast, the waves actually slow down as they interact with the seabed, and as a result of this, because the shoreline is uneven, the slowing down is at a different rate. So when you have refraction occurring, the waves converge on the headlands, giving it a higher wave height and greater erosional energy. So when you have an area where you have protruding pieces like the headlands will suffer more erosion and will be eroded away, eventually straightening the coast. Now the next section we're going to look at is coastal erosion. Coastal erosion basically is the process which changes the look of your coast. So in erosion, you will learn four main erosional methods under the acronym CASH: cohesion, attrition, hydraulic solution, and hydraulic action. Now cohesion, or also known as abrasion in this case, refers to when sediments are hurled against the coast itself. They weaken the coast and form more erosional pieces that are broken off. Over time, it is actually powerful enough to undercut a cliff and result in the top part of the cliff collapsing. The next process here is hydraulic action. Hydraulic action refers to the moment where waves strike a rock surface. Rock surfaces are uneven and often there are fractures. So when this happens, actually the water compresses the air that's trapped within these fractures, and this compression actually breaks down the rocks at a very rapid rate. When this is done repeatedly, you will have the rock front, the cliff itself, fracturing. Now the next one, attrition, actually doesn't affect the coastal area directly. Attrition is the process whereby sediments that are carried within the water itself hit one another and in the process are broken down into smaller pieces. Another side effect of this is that the sediments tend to become very rounded and smoothen when they hit one another within the water solution itself. And the last erosional method that we're going to look at is solution. Solution has got to do with a chemical reaction within the water-soluble minerals found in the rock surfaces and the seawater itself. So for example, if you have very weak rocks or chemically soluble rocks like limestone, which will be very easily eroded by carbonic acid, you will have very high erosion rate due to solution itself. So when you talk about solution, we're looking at the type of rock found, whether it has soluble minerals or not. Now, after talking about the concept of erosion, you've broken down the pieces, you need to move them somewhere else. So the process is now, we're looking at is now coastal transportation. Now for this, we are looking at longshore drift. Longshore drift refers to the movement of beach particles along the beach, following the direction of longshore current, which is then once again affected by dominant wind direction. So longshore drift means particles actually refers to particle moving in at an angle aligned with the wave direction and longshore drift current, and then moving in with swash, coming out vertically parallel to your perpendicular to your coast, as it's being pulled by gravity, and it continues in this zigzag manner along the coast itself. So materials are brought from one end of the coast to another due to longshore drift. Now after you erode and you transport, the final bit of course is deposition. So when wave energy decreases sufficiently, the waves are unable to carry the sediments and it will start depositing them. Now what type of sediments are deposited first? Large sediments, because they are the ones that are heaviest. Once the wave starts losing energy, it's no longer able to carry these large particles, so large particles are always deposited first. Now if you look at the textbook itself, there is a table that shows you the size of sediment and what is the descriptor of the sediment. You do not need to memorize the size, but it's very useful to know in terms of the sizing, because when you do GI, sometimes you will be sorting it, the sediment material you find in terms of the sediment type. Now cliff, as shown in the diagram here, is actually a steep and near vertical rock face found along coast. Generally, it's formed by the action of waves undercutting a steep rocky coast itself. So if you look at these four pictures here, four diagrams, they actually show you the steps in which a cliff can be formed, and over time how it will retreat backwards into the coast itself. So the main forces at work here are hydraulic action and abrasion, because when you have an initial notch forming, is these actions when they appear during the high tide and low tide times that allow it to hollow up the notch and deepening it and forming a cave. With further erosion, the roof of the cave will collapse, and what you end up with is a steep cliff with debris that's left in situ at the bottom of the cliff itself. Over time, when the cliff base is lengthened and the cliff surface actually retreats backwards, you end up with a shore platform at the bottom of the cliff. Another major landform that you need to learn how to explain with regards to its formation, sometimes with the aid of a fully labeled diagram or fully annotated diagram, is formation of headlands and bays. Now, key to this point here is the idea that your coastal areas come with parallel bands of resistant and less resistant rocks. Okay, so when you have this geological criteria met, then it's possible to explain why, with erosion, you form the bays in between your headlands first, because the bays tend to be of less resistant rock and they get eroded further away. Now this next part here actually explains the formation of caves, arches and stacks. So sometimes when you have a headland that's protruding out into the bay itself, due to wave refraction, caves may form along the side of the headland. When caves are eventually eroded through, you'll end up with an arch, and over time, with more and more erosion, the arch may collapse, and what you're left behind is a stack. So these three set of diagrams that you see here together explain the formation of caves, arches and stacks. Now that we've looked at some of the erosional landforms, we're going to look at the depositional landform itself. The most common one, of course, are beaches. Beaches are zones of deposition where sediment is dropped as a result of the wave losing energy. Now, beach can be formed from loose sand, gravel, pebble, and sometimes even broken coastal materials like shells and corals. So the type of beach you find may vary. It may not always be the sandy beach that we have imagined in our minds. Another depositional landform that can be formed is, of course, the spit. Now, spit is formed when you have a breakaway in your coast direction. So as a result of the breakaway, the speed of the wave drastically drops off at the moment in time. So what you have is basically longshore drift bringing sediments along the coast, and suddenly with a change in direction of the coast, you have deposition in the ocean itself. So with enough time, enough sediment is gathered and you form a spit that extends outwards into the sea. Linked to the formation of a spit is the formation of a tombolo. So the same processes of longshore drift as well as meeting a coast that breaks away, it applies here. You need to form a spit first, and the spit needs to roll forward and outwards until it touches another island or another piece of land. So this interconnecting sediment bar that is out in the ocean, that used to be part of a spit, when it connects with the island or another part of the land, is now termed as a tombolo. Now structurally and in terms of composition wise, the tombolo and the spit are exactly the same. Okay, the only difference is whether it connects to another piece of land or an island on its own. The moment it does so, you cannot term it a spit, it becomes a tombolo. So we have covered erosional processes, erosional landforms, transportation processes, longshore drift, transportation of the landforms, and then of course depositional landforms like the beaches, your spits and your tombolos. So thank you for staying with us on the video, and come back soon for theory 2 of coast. So subscribe to the channel and give us a thumbs up.